Hey class, I wanted to go over a couple of things that you can take away from this semester, um, and what I think is most important going into the second semester for AP, what you will definitely see on the AP test, okay, which we'll do a good review next April before you take the exam. I'll give you some clues as to what will be on it, but anyways, you certainly had all the discrete probability distributions and probability rules, and you have to read a histogram and, interpret a histogram and a box of whisker plot. That's pretty much what it boils down to in AP stats. But, in addition to that, this idea of a sampling distribution, the central limit theorem, and how important the normal probability distribution is. So certainly you should know things like we found out with Chebyshev's rule that in any distribution, no matter what the shape, you're going to have a certain amount of data between certain number of standard deviations. But the one you really should remember is for the normal distribution, and that's the empirical rule, and that's the 68, 95, 99.7 rule. So if you have a symmetric distribution, 68% of your data lies within one standard deviation, 95% within two standard deviations, and 99.7 within three standard deviations. And of course, we can start, finding out particular percentages, even if it was 1.5 standard deviations. When we convert to Z units and stuff like that, we can find out how much. But I really wanted to get at the idea of a sampling distribution, and so I'm going to show you how that works, hopefully, on the calculator. I'll scroll through this textbook. This is one of the textbooks I use for reference. This one is, I forget which, Understandable Statistics. There's a couple of others, though, that I have in here that I can get electronic versions to. These days, even though you do have tables, Z tables, I'll show you what those look like. You do have a Z table included, usually on any AP test or, that you take. You can also get a lot of these probabilities. These are just lists of probabilities for various Z values, 1.1 standard deviations above the mean, and then it'll give you stuff. But the calculator sure works great, and as long as they let you use it, it's a lot easier to get those values out of the calculator, I think. But let's get back to this idea of a sampling distribution. Okay, so I will scroll down here to some data. It's in this book, and it's also in my calculator. I can find it. Okay, here it is. This is data for fishing for a lake up in Wisconsin, and this was done by some graduate students. And basically, they kids were allowed to fish in this lake all summer long, and they get a limit of 5 trout. And so this graduate student, as children, so they got 100 different students here, okay, and they've caught 5 trout, and then, she finds the mean length of those 5 trout, okay, and then you get this over here as a sampling distribution. So, let me just show you what that looks like when you graph this, let's say in a histogram. So I've put this data. This data also comes with us. I can download it from this book. That's why I use it. So I got it in the calculator here. So I'm going to plot a histogram of the raw trout data. Okay, so go over here and turn on my calculator, choose histogram, and let's see, I think it's raw trout. I'm going to go look it up. Yeah, it's this one, raw GR. That's all of these numbers, not the means. This isn't the sample means. This is this 500, these 500 fish caught in the lake. Okay, so that's that. And then the other thing I want to do is set the window. And I'm going to say that the window is from, I'd say 5 to 15. I don't think there's anything longer than 15 inches or shorter than. And remember, my scale for the histogram is going to be a high value minus low value divided by, let's say we want five rectangles here, so our high value might be, I see there's one that's 13. We'll say 14 minus 6 is 7 divided by 5. I don't know. I'll say 1.5. And then go over here. We'll probably have to do 100. I don't know. Hard to say. It's getting there. About 250. We'll take half of our samples. Let's say 200. Get it, fill the screen up a little bit more. Yeah, that's not too bad. Okay. I'm going to change the scale on this. 2 maybe? What's that look like? Could be 1.8. I do 2, it extends out of the screen. Let's try 1.8. Hopefully you know what I'm doing. I'm not building this histogram manually. I'm spacing the x-axis, every 1.8 inches. And remember, these are intervals, so I'll have so many fish that fall into this interval, so many fish that fall into this interval. Let's see what 1.8 looks like. Problem is, I'm going to extend the y-axis. I don't want to extend it too much. About 220. That doesn't do it either. Anyway. Let's go to 230. Let's try that. Man, serious? 250. Trying to get a good look at this data distribution. I guess I'll go back to 250. Oops. Ooh, graph. Okay, that's not too bad. And if you look at it, you can see it's pretty normal. I mean, maybe not. Maybe it's kind of to the high end. It might be skewed a little bit this way. I would guess it would be a little bit skewed. Even though height and length and width and stuff like that tend to be normal distributions, you have to remember this is at a lake and they're catching fish, so they probably throw away the little ones. So that's why you don't get a lot of data down on this end. Okay, but you get a normal distribution, and we can find the mean. We can find the mean of this and the standard deviation of this distribution. Okay, but it is probably skewed a little bit to the high side, mainly for that reason. People don't keep the small fish. They tend to throw the small fish away. But for the most part, most of the fish lie in this area here are going to be within somewhere between 8.6 and 10.4 inches long, and then it comes down on either side. Okay, so let's go over and calculate the stats for that one. Variable statistics for raw trout. So I'll go find that list. These calculators are really handy. Any program, this day and age, you got to use a program to deal with data. I mean, it's just very difficult to do it by hand anymore. There's so much data in this world. That's why you really should be a statistician, because there's just always opportunity to do stuff. Everybody, what this world does is collect data, and knowing how to interpret that data, organize it, analyze it, is really where it's at this day and age. And all of my students that go on to college and go on to their careers tell me that's the case, So, so for raw trout, so we have a mean of 10.16, and we have a sample standard deviation. Well, they're both very close because this is a lot of data. It's 500 fish, so 1.37 is the standard deviation. Now, let's go over and look at our data from, in fact, I'll do this in part 2, so just recall these numbers, okay, because this video is already getting long and I have to upload it, and it takes long for about every minute. Here it takes about 5 minutes on the thing, so I'll stop the video here and kind of recall what we did with our raw data, okay?